October 3rd, 25 was supposed to be a day of noise. It was supposed to be a day of cheering, of champagne corks popping, and of scientists high-fiving each other in control rooms. It was the day that the object known as 3I Atlas was scheduled to make its closest approach to the planet Mars. In the history of astronomy, few things had promised to be as exciting as Atlas. It was an interstellar visitor, meaning it came from outside our own solar system, travelling from the deep dark void between the stars. It was moving faster than any comet or asteroid that belongs to our sun. It was a traveller passing through, and humanity had one chance to get a good look at it before it disappeared forever into the darkness. But instead of noise, there was only silence. On Earth, the silence was political. In a twist of fate that historians would later call a cosmic joke, the United States government had entered a total shutdown. The budget talks in Washington, D.C. had collapsed 3 days earlier. This meant that on the single most important day for planetary science in a decade, the National Aeronautics and Space Administration (NASA) was effectively closed for business. At the Jet Propulsion Laboratory in California, the parking lots were empty. The hallways, usually buzzing with the energy of brilliant minds and the smell of strong coffee, were dark. There were no press conferences. There were no live streams for the public to watch. 15,000 employees had been placed on furlough, forced to stay home without pay. They sat on their couches staring at their televisions or phones, frustrated and helpless, while the event of a lifetime was happening millions of kilometers away. Only a skeleton crew remained. This was a tiny group of essential personnel, just enough to keep the lights on and ensure the satellites didn't crash. But they were not allowed to do science. They were only allowed to monitor the health of the machines. They were caretakers in a graveyard of ambition. While the silence on Earth was born of bureaucracy, the silence on Mars was something else entirely. It was colder, deeper. We have a fleet of robotic eyes orbiting the red planet. The Mars Reconnaissance Orbiter, with its powerful camera that can see a dinner table from space, should have been snapping thousands of photos. The European Space Agency's Mars Express should have been scanning the object with radar. These machines are the most advanced explorers we have ever built. They are our sentinels. But on that day they saw nothing. Or if they did, they were not speaking. The data feeds that usually streamed back to Earth in a river of binary code were just a trickle. The Deep Space Network listened, pointing its giant white ears toward the red dot in the sky, but the result was static. The official report released months later would blame a solar interference event or a software handshake error. But in the moment, it just felt like the machines had closed their eyes. The greatest flyby in history was happening, and our billion-dollar cameras were looking the other way. The universe, however, rarely keeps secrets forever. Sometimes when the experts are blinded, it is the amateur who sees the truth. Simeon Schmaus was not a NASA scientist. He did not have a PhD in astrophysics. He was a night shift manager at a logistics warehouse in Ohio. He lived in a small house filled with computer parts, empty energy drink cans, and a very expensive telescope that he barely had time to use. Simeon was a citizen scientist. He was part of a global community of people who spent their free time combing through the raw images that NASA automatically uploaded to public servers. Even during the government shutdown, the automated systems continued to upload raw data from the Mars rovers. These were not the pretty colour-corrected pictures you see on the news. They were raw, grainy, black and white files that looked mostly like grey noise. On the night of October 3rd, while the professional scientists were worrying about their paychecks, Simeon was sitting in his dark office, the blue light of his monitor reflecting in his glasses. He was bored. He decided to check the latest batch of raw images from the Perseverance rover. Perseverance was down on the surface of Mars, sitting in the dust of Jezero crater. Its main job was to look at rocks, not the ski, but occasionally the rover would take pictures of the horizon or the Martian clouds to check the weather. Simeon downloaded a folder labelled Navcam Right. He began clicking through them one by one. Click, a grey rock. Click, more grey rocks. Click, the dusty horizon. It was tedious work. Most people would have given up after 5 minutes, but Simeon found peace in the routine. He liked the feeling of being the first human eyes to see these specific images. He reached image number 402. It was a shot of the Martian sky taken just after sunset. The sky was a washed-out grey darkening at the top. He saw a smudge. Dead pixel, he muttered to himself. He reached for his mouse to close the image, but something made him stop. He opened the next image taken 30 seconds later. The smudge was there again, but it had moved. Simeon sat up straighter in his chair. Dead pixels do not move. Dust on the camera lens does not move across the frame like that. He quickly downloaded the entire sequence, 20 images in total spanning about 10 minutes of time on Mars. He opened his image processing software. It was a program he had bought on sale years ago, but he knew how to use it better than he knew his own car. He stacked the images. This is a technique where you layer multiple photos on top of each other to reduce the noise and bring out faint details. He aligned the background stars, which were just faint pinpricks of light. When the processing bar hit 100%, the image on his screen sharpened. Simeon stopped breathing. It was not a smudge, it was not a cloud, and it certainly was not a comet. Comets are messy. They are dirty snowballs made of ice and rock. When they get close to the sun, they heat up and create a long, fuzzy tail of gas and dust. They look like nebulous blobs with a streak behind them. They are organic, chaotic, and natural. The object on Simeon's screen was none of those things. Against the grainy grey background of the Martian sky, the object stood out with terrifying clarity. It was a solid shape, it had hard edges, it was long and thin, it was a cylinder. Simeon leaned in until his nose almost touched the screen. He zoomed in until the pixels became blocky squares. The object was perfectly symmetrical. It looked like a long dark cigarette floating in the void. There was no tail, no cloud of gas, no sign of tumbling or rotation. It was just a smooth long bar gliding silently through the dark. A cold feeling washed over him. It started at the back of his neck and moved down his spine. It was the feeling of being watched, the feeling of being very small in a very large room. He looked around his messy home office, the half-eaten sandwich on his desk, the pile of laundry in the corner, the poster of the Milky Way on the wall. Everything suddenly looked different. Everything looked fragile. He looked back at the screen. The timestamp on the photos showed that they were taken hours ago. The object, whatever it was, had already passed Mars. It was moving away, heading back out into the darkness, back to wherever it came from. While the great telescopes of Earth were shut down and the orbiters around Mars were silent, this thing had slipped by. It had ghosted the entire human race. Except for him. Simeon Schmoes, the warehouse manager from Ohio, sat alone in the silence of his house. He realized he was holding his breath. He exhaled slowly, the sound loud in the quiet room. He wasn't looking at a rock. He wasn't looking at a comet. He was looking at a visitor that had refused to say hello. And in the heavy silence of that night, staring at the impossible cylinder on his screen, Simeon understood one thing with absolute certainty. We are not alone, and whoever they are not interested in talking to us. When we look at the universe, we usually use telescopes. We use mathematics charts and graphs. We count the speed and measure the light. But sometimes the tools of science are not enough to capture the full spirit of an event. Sometimes to understand a mystery, we must stop looking with our eyes and start looking with our minds. When Oumuamua passed by Earth, it created a divide in the scientific community. The astronomers saw a data point, a tumbling rock, or a strange comet. But there was another group of people who saw something entirely different. They did not use lenses or radar, they used intuition. This brings us to the story of Birdie Jaworski and the practice of remote viewing. To understand this part of the story, we have to accept that the human mind might be capable of travelling where the body cannot. Remote viewing is a concept that has been studied by intelligence agencies and governments for decades. It is the ability of a human being to quiet their mind, enter a deep state of focus, and describe a location or an object that is thousands or even millions of miles away. It sounds like magic, but for practitioners like Birdie Jaworski, it is a discipline. When Oumuamua entered our solar system, Birdie Jaworski turned her focus toward it. She did not see a dead, cold, cigar-shaped rock. In her session, she described something that felt built. She described a feeling of structure. She saw walls, she saw intentions, and most importantly, she saw a beacon. In her vision, the object was not tumbling aimlessly, it was broadcasting. She used the word lighthouse to describe the sensation. A lighthouse does not move to attack you. It stands still and shines a light to guide you or to warn you or simply to say, I am here. This was a radical departure from the scientific view. While scientists were arguing about hydrogen outgassing and gravitational pulls, the intuitive community was sensing a presence. They felt that Oumuamua was not a what, but a who, or at least a creation made by a who. This intuitive perspective invites us to look at the object through a powerful metaphor, the cosmic thumb drive. Imagine for a moment that you have a USB drive, a thumb drive in your pocket. It is small, perhaps made of plastic and metal. If you were to drop it in the mud, it would look dirty. If you wrapped it in a ball of tape, it would look like a piece of trash. But the outside appearance does not matter. The plastic shell is just a container. The mud is just camouflage. The only thing that matters is the data stored inside the memory chip. Oumuamua could be exactly like that. Scientists tell us it looked reddish and rocky. They tell us it might have had a layer of organic insulation, like a crust formed by millions of years of radiation. But what if that crust is just the protective case? What if the rock and the ice are just the packaging for something much more precious hidden inside. Think of it as a delivery package. When you order something valuable online, it arrives in a cardboard box filled with bubble wrap. If an alien found that box, they might think, "Oh, this is just cardboard and plastic." They might miss the brand new phone hidden in the center. The theory here is that Oumuamua is an ancient hard drive, a storage device carrying the history, the knowledge, or the DNA of a civilization that might be long gone. It was wrapped in a thick layer of ice and rock to protect it from the harsh environment of deep space. Space is dangerous. There are micrometeoroids, cosmic rays, and extreme temperatures. If you wanted to send a library of information across the galaxy, you would not send a delicate book. You would encase it in a shield. You would hide it inside a rock. This leads us to the profound concept of consciousness communicating. If Oumuamua is indeed a technological object, it changes our relationship with it. A rock is dead matter. It has no will, no intent. But a machine, especially a highly advanced machine, mimics consciousness. The intuitive view suggests that Oumuamua was not dead. It was dormant. It was sleeping. It was in a low-power mode, drifting through the emptiness of the void for hundreds of thousands of years, waiting for a trigger. What was that trigger? Perhaps the warmth of our sun. As it approached our sun, the object woke up. The non-gravitational acceleration, that mysterious push that scientists couldn't fully explain, might not have been gas escaping. It could have been the machine turning on its engines. It could have been the consciousness of the device recognizing that it had arrived in a habitable zone. It sensed the sun, it sensed the planets, and perhaps it sensed us. The idea of consciousness communicating suggests that the universe is not a silent room. It is a network. Just as our computers talk to each other over the internet, advanced civilizations might speak to each other through physical objects sent across the stars. Oumuamua might be a ping, a signal sent out to check if anyone is online. It feels spiritual because it touches on our deepest fear, the fear of being alone. If Oumuamua is a message, then we are not orphans in the universe, we are neighbors. To truly understand why this is plausible, we only need to look in the mirror. We need to look at our own history. We have done the exact same thing. In the late 1970s, humanity launched the Voyager 1 and Voyager 2 spacecrafts. These were our first true ambassadors to the stars. Attached to the side of these spacecrafts is a phonograph record, the famous Golden Record. The Golden Record is a copper disc plated with gold. It contains sounds and images selected to portray the diversity of life and culture on Earth. It has recordings of wind and thunderbirds and whales. It has music from Bach, Beethoven, and Chuck Berry. It has greetings in 55 ancient and modern languages. It even has the brainwaves of a woman falling in love. Why did we build it? We knew the chances of aliens finding it were incredibly small. It was a bottle thrown into the largest ocean imaginable. We built it because of hope. We built it because we wanted to say we were here, we lived, we created music, we felt love, please remember us. If we, a young civilization that has only had electricity for a few hundred years, have the desire to send our memories into the stars, why wouldn't an older civilization do the same? If a culture existed 1 billion years ago, and they knew their star was dying or their planet was doomed, they would not just accept oblivion. They would try to save something. They would build a time capsule. They would construct a durable shielded vessel like Oumuamua. They would load it with their art, their science, their history, and their genetic code. And they would throw it out into the dark, hoping that one day a species like us would find it. When we compare Oumuamua to the Voyager, Golden Record, the mystery becomes less scary and more beautiful. It becomes a story of connection. The Golden Record is our thumb drive. Oumuamua is their thumb drive. This perspective shifts the atmosphere of the discussion. We move away from the cold calculations of velocity and trajectory. We enter a space that is deep, quiet, and spiritual. We start to feel a heavy, solemn emotion. Imagine the loneliness of that object. It has travelled through the absolute darkness for eons. It has passed empty stars and frozen nebulas. It carries the weight of an entire civilization inside its rocky shell. It is a ghost ship sailing on the black tides of the galaxy. When it passed Earth, it did not stop, and it tumbled past us, accelerating away, disappearing back into the night. This adds to the sense of longing. It was a brief encounter. Two strangers passing on a dark street. We looked at it, and perhaps it looked at us. The intuitive crowd, the people like Birdie Jaworski, argue that the connection happened on a level we cannot measure with instruments. They believe that simply by observing it, simply by focusing our collective consciousness on it, we interacted with it. We acknowledged it. In quantum physics, the observer affects the observed reality. In a spiritual sense, our attention gave the object life. We witnessed its journey. So when we think about the time capsule, We are thinking about a bridge between the material world and the mental world. The object is physical, it has mass, it reflects light, it has speed. But its purpose is mental. It carries information, it carries memory, it carries intent. It challenges us to expand our definition of life. If a machine can carry the soul of a culture, is it truly dead? If a rock contains the instructions to rebuild a civilization, is it just a rock? The silence of Oumuamua is not empty. It is a pregnant silence. It is the silence of a library at night where thousands of books are sitting on shelves waiting to be opened. The words are there, the stories are there, the wisdom is there, they are just waiting for a hand to reach out and open the cover. We may have missed the chance to physically catch Oumuamua. We did not have the rockets ready to chase it down and drill into its surface. We could not plug it into our computers to read the files. But perhaps we received the message anyway. The message was the event itself. The arrival of the object forced us to look up. It forced us to ask, are we alone? It forced us to consider that the universe is full of relics, ruins, and memories floating in the dark. The thumb drive metaphor tells us that value is hidden. The remote viewing story tells us that we have senses we rarely use. The comparison to Voyager tells us that the desire to communicate is universal. As Oumuamua fades into the distance travelling toward the constellation Pegasus, it remains a symbol. It is a monument to the endurance of intelligence. It is a promise that even if a civilization falls, its echo can last forever. The ice may be cold and the rock may be hard, but the heart of the time capsule is warm with the data of a life once lived. It continues its journey a silent sentinel, carrying its secrets to the next star, and the next, and the next. The data that broke the models. The initial images of 3i Atlas were confusing, but the telemetry data, the raw numbers streaming back from our deep space sensors, was terrifying. In the quiet hum of the control room, the excitement of discovery slowly curdled into a heavy silent awe. We were no longer looking at a rock. We were looking at a physics textbook written in a language we did not speak. In the scientific community, we often talk about the standard model of cosmology. It is the rulebook that tells us how stars form, how comets behave, and what the universe is made of. But as the data from 3i Atlas filled our servers, it began to violate those rules one by one. We jokingly called the report the 7 Impossible Things, a reference to Alice in Wonderland believing as many as 6 impossible things before breakfast. But there was nothing funny about the reality of it. Here is the breakdown of the anomalies that forced us to accept that we were not alone. The first impossibility. The mass problem. The first thing an astronomer does when a new object appears is to weigh it. We do not put it on a scale, of course. We watch how it interacts with gravity. We observe how it pulls on other things or how much force it takes to move it. A standard comet is essentially a dirty snowball. It is made of frozen water dust, methane and rock. It is light and porous. If you held a piece of a normal comet in your hand, it would feel like pumice stone or styrofoam. The density of a typical comet is usually less than 1 gram per cubic centimetre lighter than water. When we calculated the trajectory of 3i Atlas, our computers crashed. The simulation could not reconcile the object's size with its movement. Based on its visual size, it should have drifted easily under the influence of Jupiter's gravity. But it didn't. It punched through the gravitational fields of the outer planets like a cannonball moving through fog. When we finally pinned down the numbers, the room went silent. Our Atlas was not made of ice. It was not even made of rock. The density readings suggested a mass that was impossible for an heavy object of that diameter. To match the gravitational pull it was exerting, it had to be denser than lead, denser than gold, perhaps denser than anything on the periodic table. We were faced with 2 impossible options. Option 1. The object was made of degenerate matter, the kind of supercompressed material you find in the heart of a collapsed star, which should not exist in a stable form flying through space. Option 2. The object was not solid at all, but contained a mechanism that was generating its own artificial gravity field, warping the space around it. We were looking at a small moon with the weight of a planet. It felt like watching a ping-pong ball land on a table and shatter the wood. It defied our understanding of how mass works. The second impossibility. The chemical fingerprint. If the mass was a puzzle, the chemical composition was the smoking gun. Astronomers use a tool called spectroscopy to figure out what things are made of. By analysing the light reflecting off an object, we can see barcodes of colour. Every element has a unique barcode. Hydrogen looks one way, carbon looks another. In the natural universe, elements follow strict rules of association. Stars act as factories. They fuse hydrogen into helium, then into heavier elements like carbon, neon, and oxygen. When massive stars die, they create iron and nickel. In nature, iron and nickel are like twins. They are almost always found together. If you find a meteorite made of metal, it will always be a mix of iron and nickel. That is the signature of a stellar explosion. When the spectroscope results for 3I Atlas came back, the lead chemist thought the machine was broken. He recalibrated it 3 times. The result remained the same. The surface of 3I Atlas was composed of nearly 100% pure nickel. There was no iron, none, 0. This is profoundly unnatural. In the chaos of the universe, nature does not sort atoms. Nature mixes them. To get pure nickel without a single trace of iron requires a process called smelting. It requires a furnace. It requires separation tanks. It requires a conscious effort to purify a metal for a specific engineering purpose. Finding pure nickel in deep space is like walking through an untouched forest and finding a perfect cube of stainless steel sitting on a mossy rock. It proved that 3I Atlas was not born from a dying star. It was manufactured. The crust of the object was likely a shield, a high-grade alloy armor, designed to withstand the impacts of interstellar travel over millions of years. The third impossibility. The WOW connection. While the chemists were panicking, the orbital dynamics team uncovered something that sent chills down our spines. They ran the trajectory of 3I Atlas backward in time. In space, everything moves in curves. By calculating the speed and direction of the object, we can trace its path back to where it came from. We wanted to know which star system had launched this traveller. The computer drew a line back through the darkness out of our solar system, past the Oort cloud and into the deep void of the constellation Sagittarius. The origin point aligned perfectly, not roughly, but exactly with a specific set of coordinates. These were the coordinates of the Gahuao signal. In the year 1977, a radio telescope in Ohio picked up a blast of radio waves so strong and so unique that the astronomer on duty circled it and wrote, "Wow," in the margins. It was the strongest candidate for an alien transmission we had ever received. It lasted 72 seconds and then vanished, never to be heard again. We had spent decades listening to that empty spot in the sky, wondering if anyone was there. The trajectory analysis of 3I Atlas suggested that the object had been travelling at a specific cruising speed that matched the timeline perfectly. If a civilization in Sagittarius had sent a radio ping in 1977 and simultaneously launched a physical probe, the timing of 3I Atlas's arrival was not a coincidence. The WOW signal wasn't just a hello, it was a doorbell. And now, 40-some years later, the guest was standing on the porch. The fourth impossibility, the wrong-way tail, perhaps the most visually spectacular and physically confusing aspect of 3I Atlas, was its tail. When we think of comets, we think of a long, beautiful tail streaming behind them. This happens because the heat of the sun melts the ice on the comet. The solar wind, a stream of particles blowing out from the sun, pushes this gas and dust away. Therefore, a comet's tail always points away from the sun. If a comet is moving toward the sun, the tail is behind it. If the comet is moving away from the sun, the tail is actually in front of it, blowing outward. Atlas had a tail, but it was wrong. As the object approached the inner solar system, a jet of blue plasma ignited. However, this jet was not pointing away from the sun, it was pointing directly at the sun. In terms of orbital mechanics, this makes no sense for a natural object. If gas is venting towards the sun, it means the object is fighting the solar wind. But to an engineer, it made perfect sense. If you're in a car moving at high speed and you want to stop, you apply the brakes. In space, to slow down, you have to fire your engines in the direction you're traveling. You have to push against your momentum. Atlas was not melting, it was braking. The blue flame was a retro thruster. The object was travelling at incredible interstellar speeds, hundreds of kilometers per second. If it hit our atmosphere at that speed, it would vaporize instantly. To enter a stable orbit or to land, it had to shed massive amounts of velocity. The energy output required to generate that blue plasma tail was staggering. It was putting out more energy in a few seconds than a nuclear power plant produces in a year. And it was directing this energy with surgical precision. The tail would shift slightly, adjusting the angle of the object, correcting its course by fractions of a degree. This was active piloting. The atmosphere in this room. The realization of insignificance. As these impossibilities stacked up, the impossible weight, the industrial purity of the metal, the historic trajectory and the active braking maneuvers, the mood in the scientific community shifted from curiosity to a profound sense of humility. For centuries, humans have looked at the stars and wondered if we are special. We built our little rockets, We were proud of our rovers on Mars. We patted ourselves on the back for splitting the atom. We thought we were the masters of physics. But 3i Atlas silenced our ego. Young, we were looking at technology that was not just advanced, it was godlike. The physics required to manipulate gravity, the mass problem, is something we only have theoretical scribbles about. The metallurgy required to build a hull of pure nickel, the chemical problem on a planetary scale, suggests an industrial capacity millions of times greater than all of Earth's factories combined. The ability to navigate the void between stars and arrive at a precise destination after decades of silence, the orbit problem implies a patience and mathematical understanding that dwarfs our own. We felt like a tribe of islanders who had mastered the art of building wooden canoes, suddenly watching a nuclear-powered aircraft carrier rise out of the ocean. It was beautiful, yes, the mathematics of its movement were elegant, the efficiency of its braking burn was poetic, but it was also terrifying. It made us realize that we are not the main characters in the story of the universe. We are the ants, living in the crack of the sidewalk, and a giant has just stepped into our view. The object was now passing the orbit of Mars. The braking sequence was intensifying. The blue plasma flame grew brighter, visible even to amateur telescopes on Earth. It was slowing down. It was coming here. And the physics of its arrival told us one final, undeniable thing. It was not crashing, it was parking. The camera pulls back, leaving the small, fragile surface of the Earth behind. We travel upward, past the clouds, past the moon, and into the deep, silent blackness of space. The silence here is heavy, but it is not empty. We have arrived at a very special moment in time. It is October 2025. To the human eye, space usually looks dark and still, but right now the solar system is screaming with energy. It is a time of violence, but also a time of breathtaking beauty. At the center of this stage stands the sun. In this year, the sun is not the calm yellow circle we draw in children's books. It is a raging beast. Scientists call this the solar maximum. It is the peak of the sun's 11-year heartbeat, the moment when its activity is highest, strongest, and most dangerous. It looks as though the star is taking its last desperate gasps. The surface of the sun is a boiling ocean of fire. It is churning and twisting. Dark spots, which we call sunspots, cover its face like bruises. These spots are larger than the entire Earth, deep pits of magnetic force that are ready to snap. And snap they do. Huge ribbons of liquid fire, which scientists call plasma, erupt from the surface. They loop high into the sky, stretching for hundreds of thousands of kilometers before crashing back down or exploding outward. The sun is throwing parts of itself into the dark void. It is a terrifying display of power. This is the last gasp of this solar cycle, a final burst of fury before it begins to calm down in the coming years. But right now in October, it is a storm of light. These explosions send invisible waves of energy rushing toward the planets. This is the solar wind, but it is no longer a gentle breeze. It is a hurricane. When this hurricane hits the Earth, it does not destroy us thanks to our planet's invisible shield. Instead, it paints. As the sun's fury crashes into the upper atmosphere, it creates the auroras. Usually these lights are shy, they stay close to the north and south poles. But during this solar maximum, the lights break their chains. They spill down toward the equator. Great curtains of light ripple across the night sky. They are not just green, they are deep violet, blood red, and bright pink. It looks as if the sky itself is breathing. The colors fold over each other, dancing and shimmering, turning the dark night into a neon dream. It is nature's greatest light show, powered by the angry breath of our dying star. But the sun and its painted skies are not the only actors on this stage. While the sun rages in the center, 3 silent travelers have arrived from the frozen edges of the solar system. These are the green comets, Comet Lemon, Comet Swan, and Comet Atlas. They have traveled for thousands of years to be here. They come from the cold, dark places where the sun is just a tiny star in the distance. They are mountains of ice and dust, frozen relics from the birth of time. As they get closer to the heat of the angry sun, they begin to wake up. The ice upon their backs turns instantly into gas. This gas forms a cloud around them, a glowing halo that astronomers call a coma, because of the specific chemicals frozen inside them. Mostly a substance involving carbon, they do not burn yellow or orange. They burn with a ghostly, brilliant emerald green light. It is a color that feels alien, a sharp electric green that cuts through the darkness. First there is Comet Lemon. It is bright and sharp, moving with a steady determination. It looks like a green gemstone thrown across a velvet table. Its tail is long and thin, trailing behind it like a bride's veil made of stardust. Then there is Comet Swan. As its name suggests, it is graceful. Its tail is wider, fanning out like the wings of a great bird flying through the void. It seems to glide effortlessly, indifferent to the magnetic storms raging around it. Finally, there is Comet Atlas. It is the heavyweight of the trio. It glows with an intense intensity, a thick, fuzzy ball of green light that seems to pulse. It is a grand ancient wanderer that has seen this solar system change over millions of years. The scene is set for a cosmic ballet that has never happened quite like this before. Imagine the picture in the background. You have the deep, endless black of the universe. In the center, the sun is exploding with flares, sending out waves of invisible power. Wrapped around the Earth are the shimmering curtains of the aurora, glowing pink and purple. And cutting across this chaotic, colourful background are the 3 green comets. It is a contrast of fire and ice. The sun is hot red and violent. The comets are cold green and silent. The sun screams, the comets whisper. The tails of the comets stretch out for millions of kilometres. As the solar storm hits them, the tails twist and wobble. The solar wind acts like a strong fan blowing against smoke. The tails of Lemon Swan and Atlas ripple in the wind. Sometimes a piece of the tail might break off and drift away, carried by the sun's breath. For an observer floating in space, the view is majestic. It makes you feel very small. You realise that the solar system is not a quiet, empty machine. It is a living, breathing organism. The comets are like visitors entering a ballroom where a wild dance is happening. They join the dance, their green trails mixing visually with the red and purple lights of the solar storm. It feels poetic. The last gasp of the solar maximum is not a death. It is a celebration of energy. The sun is showing us its power one last time before it sleeps, and the comets, these icy messengers from the dark, have arrived just in time to witness it. They are the emerald guests at the king's final feast. The atmosphere is filled with a sense of awe. There is no sound in space, yet the visual noise is deafening. The brightness of the comets, the violence of the solar flares, and the ghostly dance of the auroras create a harmony. It is a reminder that beauty often comes from chaos. The magnetic storms that could disrupt our radios and satellites are the same storms that create the art in the sky. The heat that could burn us is the same heat that lights up the tails of the comets. As October marches on, the position of these celestial bodies shifts slowly. Every night the dance changes slightly. Comet Lemon moves higher, Comet Swan dips lemons lower. The auroras fade and then burst back into life with every new explosion from the sun. It is a dynamic, ever-changing painting. This is the grand design of the universe on display. It is elegant and terrifying all at once. The green comets act as a cool, soothing balm against the fever of the sun. They remind us that the universe is vast and contains both extreme heat and extreme cold. In this moment, looking at the 3 green dots sailing through the magnetic storm, one cannot help but feel a sense of wonder. It is a rare alignment, a coincidence of timing that brings the peak of the sun's cycle together with the arrival of these deep space wanderers. It is as if the universe arranged a special performance for us, a symphony of light and motion played out on the biggest screen imaginable. The green glow of the comets reflects off the dust in the solar system, creating a hazy, magical atmosphere. If you could stand on the surface of one of these comets looking back at the sun, you would see a star that looks angry and swollen, surrounded by the halo of its own atmosphere. And you would see Earth, a tiny blue marble crowned with a ring of dancing aurora lights. This is the dance of October 2025. It is the solar system showing off. It is a moment where science and poetry become the same thing. The physics of burning gas and magnetic fields becomes a story of dragons and jewels. The sun, in its final moment of peak strength, roars into the dark, and the green comets bow in response, their emerald tails streaming behind them like banners in the wind. It is a glorious, fleeting moment in the endless history of the stars. For decades, humanity has looked up at the night sky and felt a profound sense of loneliness. We saw stars, we saw darkness, and we saw the steady, predictable movement of the moon. The universe felt vast, empty, and quiet, but recently that silence has broken. The neighbourhood surrounding our planet is no longer a quiet suburb of the galaxy. It has become a busy, noisy, and potentially dangerous intersection. As we moved through the middle of the year, a series of disconnected events began to paint a worrying picture. From the frozen wastelands of Antarctica to the red dust of Mars and the scorching deserts of the Middle East, the message was clear. We are not alone. We are not unsafe, and we are definitely being watched. The first wake-up call came from the bottom of the world, in a place where the only natural sounds are the howling wind and the cracking of ice. It involved an object now catalogued as Asteroid 25TF. For planetary defense astronomers, the worst nightmare is not the asteroid you see coming years in advance. It is the one you do not see until it is already waving goodbye. That is exactly what happened with 235TF. This was not a planet killer, but it was large enough to destroy a major city. It was a rock roughly the size of a 14-story building moving at speeds that make a rifle bullet look like it is standing still. The reason no one saw it coming was simple, but they're terrifying. It approached Earth from the direction of the sun. In the world of astronomy, the sun is the ultimate blind spot. Our telescopes cannot look directly at it without being blinded by the glare. 2025. TF hid inside that glare, masking its approach perfectly. It was only when the rock passed into the shadow of Earth over the frozen expanse of Antarctica that the automated system finally picked it up. By then, the event was already over. The asteroid had skimmed the upper atmosphere, passing within a distance that is terrifyingly close in cosmic terms, closer than our own television and weather satellites. The data that came in the following morning sent a chill through the scientific community that had nothing to do with the Antarctic cold. If the trajectory of 235TF had been just a tiny fraction of a degree different, it would not have skipped off the atmosphere. It would have slammed into the ice shelf. The impact would have released energy equivalent to a large nuclear weapon. It would have vaporized millions of tons of ice instantly, sending a shockwave through the southern hemisphere and potentially triggering tsunamis. The public was told it was a close shave. But inside the control rooms, the mood was heavy. It was a stark reminder of our blindness. We rely on technology to keep us safe, yet a city-killing rock had just buzzed our tower, and we did not even know it was there until it was gone. The sky felt suddenly lower and much more fragile. While the astronomers were wiping sweat from their brows over the near miss in Antarctica, a different kind of shockwave was rippling through the scientific community regarding our neighbour Mars. For years, the rovers crawling across the Martian surface have been looking for signs of water and ancient geology, but the rover exploring the region known as Sapphire Canyon found something that changed the conversation from geology to biology. Sapphire Canyon is a jagged cut in the Martian landscape, an area believed to have been a rushing river billions of years ago. The rover paused at a rock formation that looked unusual. It extended its robotic arm, drilled into the surface, and captured high-resolution images that were beamed back to Earth. When the images loaded on the screens at NASA, the room went silent. The rock was covered in what scientists are now calling leopard spots. These were not just random discolorations. On Earth, rocks with these specific millimeter-sized spots are almost always formed by microbes. When tiny living things interact with minerals in water, they create chemical reactions that leave these distinct marks behind as a fossilized record. They are the fingerprints of life. The discovery of the leopard spots in Sapphire Canyon is the strongest evidence we have ever found that Mars was once alive. It suggests that billions of years ago, before Mars lost its atmosphere and froze over, it was a living, breathing world just like Earth. But this discovery brings with it a haunting implication. If life was there, where did it go? Did it die out naturally, or was it extinguished? And if life can rise and fall on the planet right next door, what does that say about our own longevity? The leopard spots are a scientific triumph, but they also serve as a memento mori, a reminder of death. They turn Mars from a dead rock into a graveyard. It makes the solar system feel less like an empty room and more like a house where the previous tenants mysteriously vanished. If the asteroid highlighted our blindness and the Mars discovery highlighted our mortality, the events in Yemen highlighted our vulnerability to things we simply do not understand. The incident took place in a conflict zone, a place where the sky is usually filled with the noise of drones and fighter jets. However, a leaked piece of footage from a military targeting pod has confused intelligence agencies and physicists alike. The video is grainy, shot in black and white thermal imaging, but the details are unmistakable. The footage shows a standard engagement. A drone is tracking a target moving on the ground. Suddenly a third object enters the frame. It is not a plane, it is not a bird, and it is not a drone. It is a perfect metallic sphere hovering motionless in the air despite the high winds. It has no wings, no rotors, and no visible engine exhaust. It sits in the sky like a hole in reality. In the video, a Hellfire missile is fired. These missiles are designed to destroy heavy tanks. They travel at supersonic speeds and pack an incredible explosive punch. The missile streaks toward its target, but then something impossible happens. The missile strikes the hovering metal sphere. According to the laws of physics, one of two things should happen. The missile should explode and destroy the sphere, or the missile should punch through the sphere. Neither happened. Instead, the missile bounced. It ricocheted off the sphere as if it were a rubber ball thrown against a concrete wall. The missile spun away wildly and detonated harmlessly in the desert sand. The sphere did not move. It did not shake. It did not even seem to register the impact. A split second later, the sphere accelerated, vertically vanishing from the camera frame instantly. The analysis of this Yemen sphere has been frantic. A Hellfire missile strikes with tremendous kinetic energy. For an object to deflect it without moving requires a mass or a density that current material science cannot explain. Or it suggests some kind of force field technology that is hundreds, perhaps thousands of years ahead of human engineering. This was not a blurry light in the distance. This was a tangible, solid object interacting with our most advanced weapons and treating them like toys. The silence from official government channels has been deafening, but the leak has confirmed what many pilot reports have hinted at for years. There are things in our sky that can outperform us in every way, and they are not afraid to be seen in the middle of a war zone. So we arrive at the big question: why is the sky suddenly so crowded and so volatile? It feels as though the Earth is under siege from all sides. We have rocks sneaking up on us from the sun. We have evidence that our neighbour Mars was once a living world that failed. We have metallic spheres in the Middle East that defy the laws of physics. Is it a coincidence? Skeptics would say yes. They would argue that we are just getting better at looking. We have better telescopes, so we see more asteroids. We have better rovers, so we see smaller fossils. We have more cameras in war zones, so we catch more oddities. But to the average person, it feels different. It feels like an escalation. The atmosphere on Earth right now is one of underlying tension. There is a sense that the protection we thought we had, the safety of being a lonely planet in a quiet corner of the galaxy, is an illusion. The asteroid 225TF proved that we are sitting ducks for cosmic debris. We are living in a shooting gallery, and we have been lucky so far. The Mars discovery proved that life is not special to Earth. It is likely common, which means the universe is crowded. And the Yemen sphere suggests that some of that crowd might already be here, watching us squabble and fight, hovering silently over our battlefields. There is a psychological weight to these events. It creates a feeling of fragility. For thousands of years, humans have acted as the masters of the Earth. We felt big, we felt important. But when you compare a human to a city-killing asteroid or a tank-busting missile to an immovable alien sphere, we suddenly feel very small. The noisy neighbours are not just making sound, they are making their presence felt. The tension is not just about what has happened, but about what comes next. If a sphere can bounce a missile today, what will it do tomorrow? If a rock missed us by a hair yesterday, will the next one hit? We are looking up at the sky with a new emotion. It is no longer just wonder or curiosity. It is suspicion. It is the feeling you get when you're in a dark room and you hear a floorboard creak behind you. You know you are not alone. You know something is there. You just do not know if it is friendly or if it is waiting for the right moment to strike. The Earth is a fragile blue marble floating in a very dangerous sea. We are realizing that the waters are full of sharks and our boat is much smaller than we thought. The silence is gone. The neighbours are awake and they are very, very loud. The vastness of space has always been silent, but the silence growing on Earth is of a different, heavier kind. As we enter this new phase of history, we witness a profound and heartbreaking contrast. On one side, there is the limitless ambition of the human spirit, a desire to touch the stars that burns brighter than ever. On the other side, there is the cold, hard reality of economics and politics. We are watching a race not just against gravity, but against our own limitations. It is a race taking place in the dark where the finish line is obscured by budget cuts and the fear of failure. In the dusty plains of South Texas, the atmosphere is thick with a mixture of rocket propellant and sheer desperation. This is the home of SpaceX and the stage for Starship Flight 11. By this point in the timeline, the glossy excitement of the early days has worn off. The cheering crowds are still there, but inside the control room the mood is tense. Flight 11 represents a critical juncture. It is no longer just about innovation, it is about survival. The company has pushed the boundaries of physics, but physics pushes back hard. The massive rocket stands on the pad, a shimmering tower of stainless steel. It is the largest flying object ever built by human hands. The goal for Flight 11 is terrifyingly simple: do not explode. The engineers are not looking for perfection today, they are looking for survival. They need to prove that this beast can carry heavy loads to orbit without tearing itself apart. The vibration alone from the 33 engines is enough to shatter concrete. When the countdown hits 0, the sound is not heard. It is felt in the chest, a physical blow that reminds everyone of the violence required to leave this planet. This flight is a desperate attempt to secure the future. Contracts are on the line and the dream of a city on Mars hangs by a thread. As the rocket climbs, pushing through the thick lower atmosphere, we see the raw determination of private enterprise. They are burning money and fuel at a rate that makes governments wince. Every second the engines burn is a victory against the odds. When the separation happens and the upper stage glides into the blackness, there is a brief moment of relief. But it is fleeting. They know that to make this routine to make space truly accessible, they have to do this 100 more times without error. It is a high-stakes gamble played out with fire and steel. While the Americans fight to tame their explosive ambition, a different kind of race is happening in the East. It is quieter, more methodical, and driven by a patience that spans generations. China's Tianwen-2 mission is currently drifting through the void far from the media circus. This mission is a testament to persistence. Their target is not a flashy planet, but a small mysterious rock named Kamo'olawa. Kamo'olawa is a fascinating object. It is known as a quasi-satellite of Earth. This means it dances around our planet, staying close but never truly orbiting us like the Moon. Some scientists believe it might actually be a piece of the Moon that was broken off long ago. The Chinese mission intends to find out. The spacecraft approaches the asteroid with delicate precision. The distance is vast, millions of kilometers away, meaning that radio signals take several seconds to travel back and forth. The pilots on Earth cannot fly it in real time. They must trust the onboard computers to make decisions. The audacity of Tianwen-2 lies in its goal to touch the surface, grab a handful of dust and rock and bring it back home. This is known as a sample return mission, and it is one of the hardest things to do in space exploration. It requires a gentle touch in a violent environment. As the probe descends using its thrusters to match the rotation of the asteroid, there is a sense of national pride that does not need to shout to be heard. They are playing the long game. While others argue over quarterly budgets, this mission looks decades ahead, securing resources and knowledge that will define the next century of space dominance. However, as we look back at the West, specifically at the halls of NASA, the story takes a tragic turn. This is the most painful part of the race in the dark. For decades, NASA was the shining beacon of hope, the agency that showed us the universe. But now the lights are flickering. A crisis has set in, not caused by engineering failures, but by a lack of vision and funding from those in charge. The scientific community is in mourning. We are witnessing the slow death of legends. The Chandra X-ray Observatory, a telescope that has allowed us to see the violent hot universe of black holes and supernovas, is being choked off. It is still functional, its mirrors are still perfect, but the budget to pay the people who operate it has been slashed. It is like having a Ferrari but refusing to buy gas. The telescope drifts in orbit, a silent sentinel that is slowly going blind because we refuse to look through it. Even worse is the fate of the Hubble Space Telescope. For over 30 years, Hubble has been our eye on the cosmos. It gave us pictures that changed how we understand our place in the universe. But now the decision has been made to cancel future servicing missions. The risk is deemed too high, the cost too great. We are essentially telling our greatest explorer to die alone in the cold. This leads to a catastrophic bleeding of talent. The brilliant minds, the astrophysicists, the engineers, the data analysts are leaving. They are packing their boxes, turning off the lights in their offices and walking away. They are not leaving because they want to. They are leaving because there is no work left for them to do. This brain drain is a tragedy. These men and women go to work for finance banks or social media companies to write algorithms for advertisements, instead of algorithms for navigating the stars. We are taking our brightest minds and forcing them to look down at spreadsheets instead of up at the galaxies. The atmosphere in the agency is heavy with regret. There is a feeling of betrayal. The scientists promised the public the moon and the stars, but the politicians only gave them enough money for a low Earth orbit. Projects that have been in planning for 10 years are cancelled with the stroke of a pen. The loss of knowledge is incalculable. When a senior engineer leaves, they take 40 years of experience with them. That is not something you can replace with a computer program. The overall message of this era is a bittersweet paradox. The universe is calling to us louder than ever before. We have found thousands of planets around other stars. We have detected the ripples of gravity from colliding black holes. We know that water, the stuff of life, is everywhere. The door is wide open, yet humanity seems intent on tying its own shoelaces together. We trip over our own feet arguing about the cost of a rocket, while spending trillions on weapons and trivialities on Earth. And yet in this gloom there is still a flicker of light. It is a stubborn, defiant hope. It lives in the SpaceX engineers sleeping on the floor of the factory to make sure a valve opens correctly. It lives in the Chinese mission controllers carefully tracking a rock millions of kilometers away. It lives in the remaining NASA scientists who work unpaid overtime just to squeeze one last image out of a dying telescope. This race in the dark is B-Trang epic and tragic. It shows us that the greatest barrier to space exploration is not the speed of light or the radiation belts. The greatest barrier is the human mind, specifically our inability to value the long term over the short term. But as long as there are people willing to look up, the race is not over. We stumble, we bleed, and we lose precious time, but we keep moving forward. The rockets still launch, shaking the ground and lighting up the night sky, a fiery reminder that we refuse to stay trapped in the dark forever. The calendar on the wall of the control room seemed to stare back at the scientists. It was the end of October. Specifically, it was October 29th. In the world of orbital mechanics, dates are not just markers of time, they are coordinates in space. This date marked the most critical moment in the journey of the object known as 3I Atlas. This was the day of perihelion. To understand why this moment mattered so much, one must understand the nature of our sun. It is not merely a source of light. It is a massive roaring furnace, a gravity well of unimaginable power, and the ultimate truth teller of the solar system. Astronomers have a poetic way of describing this event. They call it the confession of fire. The idea is simple. Nothing can keep its secrets when it is standing next to a star. The trial by fire. As 3I Atlas fell toward the center of our solar system and it was picking up speed, gravity was pulling it in faster and faster. By the time it reached its closest point to the sun, the point called perihelion, it would be moving at speeds that are hard for the human mind to comprehend. We are talking about hundreds of thousands of kilometers per hour, but the speed was not the main concern. The concern was the heat. At this close distance, the radiation from the sun is intense. It is a violence of energy. For a natural object, this is a destructive process. If 3I Atlas was a comet, this would be the moment of its death or its glory. A comet is essentially a dirty snowball. It is made of frozen gases, water ice and dust. When a snowball gets close to a fire, it does not just get warm, it boils. The ice turns directly into gas, creating a massive glowing tail that stretches for millions of kilometers. This is how a comet confesses its nature. It displays a tail, it loses mass, it tumbles and cracks under the thermal stress. If 3I Atlas was an asteroid, the reaction would be different. Asteroids are rocks or metals. They are stubborn. They heat up, they might crack or fracture from the sudden temperature shift, but they generally remain dark and silent. They do not grow tails, they just endure the heat. However, there was a third option. The option that kept the scientists at the European Space Agency and NASA awake at night. If 3I Atlas was artificial, if it was a machine built by another intelligence, how would it react to the fire? A spacecraft might have heat shields. It might have materials that do not melt like ice or crack like stone. Most importantly, it might try to survive. This was the hypothesis of the confession. The heat would force the object to reveal what it was made of. Would we see the beautiful, chaotic outgassing of a dying comet? Would we see the stubborn silence of a hot rock? Or would we see something else? Would we see a correction in its path? If the object was a ship and the heat became dangerous to us, would it use engines to push itself away? Any movement that could not be explained by gravity would be the smoking gun. It would be proof of life. The great blindness. The tension in the observation rooms was thick, but it was a strange kind of tension. It was a tension of silence. This was because on the most important day of the encounter, humanity was effectively blind. There is a cruel geometry to the solar system. As 3I Atlas approached its closest point to the sun, it moved into a position that astronomers call a solar conjunction. From the perspective of Earth, the object was passing directly behind the sun, or very close to it. You cannot point a standard telescope at the sun to look for a tiny rock. The glare is too powerful. It would destroy the sensors of the Hubble Space Telescope or the James Webb Space Telescope instantly. The sun is billions of times brighter than the object we were trying to see. It was like trying to spot a mosquito flying next to a lighthouse spotlight while standing 10 kilometers away. So on October the 29th, the screens went dark. The telemetry stopped. The radar echoes faded into the background noise of solar radiation. 3I Atlas had entered the blind spot. This period of blindness was terrifying for the global community. The object was diving into the fire and we could not watch. We had to trust the mathematics. The equation said it should swing around the star and come back out. But equations cannot predict the behavior of an alien pilot, and they cannot predict if a comet will explode into dust. We were left with nothing but the waiting. The eyes of Zeus. However, humanity was not entirely without hope. While Earth was blinded by the glare, we had robots elsewhere. The European Space Agency had a mission called Zeus, the Jupiter Icy Moons Explorer. Launched years prior, this spacecraft was travelling through the solar system on its long, complex journey to Jupiter. It was not near Earth. It was millions of kilometres away on a different orbital path. The mission controllers realised that Zeus had a different angle. It was not a perfect view, and the instruments on Zeus were designed to look at ice moons, not to track fast-moving interstellar objects near the Sun. But it was better than nothing. It was a single eye open in the dark room. Engineers frantically reprogrammed the observation sequence for Zeus. They commanded the probe to turn its sensors toward the inner solar system. They were asking a traveller to look back at the fire. The hope was that Zeus might catch a glimpse of the confession. If 3i Atlas developed a massive tail, Zeus might see the reflection of sunlight off the gas and dust. If the object performed a high-energy maneuver like firing an engine, perhaps the sensors would pick up the heat signature. But the distances were vast. The data from Zeus took nearly an hour to travel back to Earth at the speed of light, and the bandwidth was low. We would not get live video. We would get tiny packets of numbers, grainy images and spectrum readings. It was a waiting game, played with light minutes and light hours. The quiet climax. The atmosphere on Earth during this week was described by journalists as a quiet climax. There were no explosions in the sky, there were no alien fleets descending through the clouds. To the average person walking down the street, the sky looked the same as it always did. The sun rose and the sun set. But in the digital world and in the academic world, the silence was deafening. Every astronomer was holding their breath. They were waiting for the object to emerge from the glare. If it survived the perihelion, it would reappear on the other side of the sun in early December. That was the timeline. October 29th came and went. The object was now officially at its closest point. It was skimming the surface of the star. We imagined the surface of the object. Was it boiling? Was the ice sublimating into space, creating a cloud of steam, or was there a metallic hull shimmering with heat shields adjusting its angle to deflect the solar wind? We did not know. The wait for December began. This was the winter of not knowing. The object was moving outbound now, travelling away from the sun and back toward the darkness of deep space. As it moved away, the angle would change. Earth would move in its orbit. Eventually, the glare would fade. The object would drift into the dark sky, where our telescopes could see it again. This was the promise of December. But for now, we had to sit with the uncertainty. The confession of fire had happened. The object had faced the star. Whatever secrets were hidden under its surface had been tested by temperatures reaching thousands of degrees. If it was just a rock, it would emerge as a hot tumbling stone. If it was a comet, it would emerge smaller, perhaps broken, dragging a tail of gas. But if it emerged unchanged, if it emerged on a new path, then we would know. The waiting rooms at the observatories were quiet. Coffee cups piled up. People spoke in whispers, as if speaking too loudly would disturb the delicate dance of gravity happening millions of kilometers away. It was a time of high anxiety disguised as boredom. The data streams from Zeus were being analysed pixel by pixel, searching for any anomaly, any flash of light that didn't belong. We were waiting for the ghost to walk out of the fire. We have arrived at the quiet end of our journey. The excitement of the discovery has settled much like dust settling on an old bookshelf in a sunlit room. The rush of data, the breathless news reports, and the late-night conversations have all faded into a soft, comfortable memory. Now there is only the silence of space and the steady rhythm of your own breathing. Let us take a moment to look back at what happened. It feels like a long time ago that we first noticed that small, wandering point of light. Do you remember? It was just a faint speck dancing against the backdrop of eternity. At first, we thought it was just another rock, a familiar neighbour tumbling through our solar system. But it was different. It moved with a speed and a purpose that told us a new story. It was a traveller from far away, a visitor that had crossed the deep dark oceans between the stars. We watched it approach. We saw it accelerate, moving faster than anything we had ever seen before. It did not orbit our sun like the other planets. It did not stay to say hello. It simply passed by, sliding through the darkness with the grace of a ship sailing on a calm sea. It dipped close to our star, warmed its frozen surface for a brief moment, and then turned back toward the endless night. We called it Atlas. We gave it a name because humans like to name things. It makes us feel connected to them. We wondered if it was a spaceship, a message in a bottle, or simply a piece of a shattered world from a distant galaxy. In the end, the specific answer matters less than the feeling it left behind. Whether it was a shard of ice or a metallic craft, it was real. It was here, and now it is gone, drifting back into the deep freeze of the void, heading toward a destination we will never know. Think about that journey. It is moving away from us now at thousands of kilometers every second, yet it is entirely silent. There is no wind in space to push against it. There is no friction to slow it down. It just glides forever, falling forward into the unknown. It carries the memory of our sun's warmth, a small souvenir from its brief time in our neighborhood. The arrival of this object has changed the way we look up at the night sky. Before, the space between the stars felt empty, like a vast, lonely desert. But now we know the truth. The space above us is not empty. It is a highway. It is full of drifting stones, wandering ice giants, and perhaps other things we have yet to see. The universe is busier than we thought, but it's a quiet, peaceful kind of busy. This realization brings us to a new horizon, a new way of understanding our place in the cosmos. For a long time we worried that we were too small, that we were insignificant specks on a blue marble. Or we worried that we were the center of everything, carrying the weight of importance on our shoulders. Atlas taught us a gentle lesson. We are neither of those things. We are not the center, and that is a relief. We do not have to control the universe, we just have to live in it. We are also not alone. Even if we never meet another living soul, we are connected to the galaxy through these wandering rocks. The same atoms that make up that distant traveler are the same atoms that make up the chair you are resting, on the water you drink and the air you breathe. We are all made of the same stardust, simply arranged in different shapes. There is a great comfort in that thought. You are part of this massive, beautiful clockwork system. You belong here. Just as the moon belongs in the sky and the fish belong in the sea, you belong right here in this moment of rest. Now I invite you to let go of the questions. The scientists will keep calculating and the telescopes will keep watching, but your job is done. You do not need to solve the mystery of the universe tonight. The universe has been around for billions of years, and it will be here when you wake up. It is patient. It can wait. Imagine the night sky above your home right now. Even if it is cloudy, even if the city lights are bright, the stars are there. They are burning quietly, steady and calm. Picture the constellation of Orion or the Big Dipper, or just a single bright star hanging in the velvet darkness. That star is like a nightlight that never goes out. It watches over the world while it sleeps. Bring your attention back to your own body. Feel the support of the bed beneath you. It is solid and safe, and let your shoulders drop away from your ears. Unclench your jaw. Let your hands rest loosely by your sides. Imagine that you are floating just like Atlas. You are weightless, drifting in a warm, safe space where nothing can touch you. There is no rush here, there is no deadline. The only thing that matters is the slow rise and fall of your chest. Breathe in, deeply filling your lungs with cool, fresh air, and breathe out slowly, letting go of all the tension from the day. Breathe in and breathe out. Picture the object Atlas one last time. It is so far away now that it is invisible to the human eye. It is entering the dark space between the stars where the silence is absolute. It is peaceful there. No noise, no chaos, just the gentle drift of eternity. It is a long, deep sleep for the traveler. You can join that peace. You can let your mind drift away from the shores of wakefulness and push off into the calm waters of sleep. Let the thoughts of tomorrow fade away. They are just clouds passing in the sky. Let them float by without holding on to them. The universe is vast and it wraps around you like a thick, soft blanket. You are safe under the protection of the stars. The earth is spinning, slowly rocking you gently in its cradle. Everything is exactly as it should be. As the image of the traveler fades into the black, let your eyes get heavy. Let the darkness behind your eyelids become a comfort. It is time to rest. It is time to turn off the mind and let the body recharge. The horizon is dark, beautiful and still. The journey is over. The stars are your guardians. Drift along with them. Float into the quiet. Good night. Sleep well.